This problem says, how long will it take for an investment to triple if interest is compounded continuously at 6%? So this problem is going to use the other interest formula that we learned. We've learned two, and so one of them was for when the interest is compounded anything other than continuously, when it's compounded quarterly, annually, semi-annually, monthly. Then we use the formula that we used in the previous problem. That was A is equal to P, parentheses, 1 plus R over K, close parentheses, raised to the K times T. And so when the interest is compounded continuously, we have a different formula for that. And so that formula is A is equal to P times E raised to the R times T. All the same variables, so they're all the same. A is going to be the ending amount. P is the beginning amount. R is the interest rate, and T is the time. Now remember, E is not a variable. E is a number. It's Euler's number. It's kind of like pi. Pi is always 3.14. E is always 2.178, so on. And so when we're plugging in what we know, we're asked how long will it take? So that means we're looking for the time. We're looking for T. We know the rate is 6%, so we'll plug in 0.06 for R. Now, it doesn't give us a beginning amount, but it does tell us that whatever we begin at, we want it to triple. So whatever our starting amount is, our ending amount, our A, is going to be 3 times that. So we can pick whatever we want to for P, as long as we put triple that or 3 times that in for A. So you could pick 1,000 for P, in which case A would be 3,000. You could pick 25 for P, in which case A would be 75. You could pick 1 for P, in which case A would be 3. Does not matter what you pick for P, as long as A is 3 times that. I'm going to pick 100 for P, because again, it doesn't matter. Pick anything you want to. So if we use 100 as our starting value, we want it to triple. So we want our ending value to be 3 times that, or 300. Again, E is a number, not a variable, but we are plugging in 0.06 for R, and then we're solving for T, so we're going to leave that as T. So here we do have an exponential because the variable is in the exponent, and it's an exponential multiplied by a number. So we need to get the exponential by itself by dividing both sides by that number first. So here I'm multiplied by 100, so I'm going to divide both sides by 100. And notice when I do, I end up with 3 is equal to 1 times, or just E to the 0.06 times T, because multiplying by 1 doesn't change anything. And so again, it does not matter what you had started with for P. If you had started with 25 and then you would had 75 for A, the first thing you would do would be divide both sides by 25, and you would end up with 3 is equal to E to the 0.06 times T. If you had started with 500 for P, you would have had 1,500 for A, divide both sides by 500, and you get 3 is equal to E to the 0.06 times T. So it doesn't matter what you start with for P. First step is going to be to divide both sides by that, and you're going to end up with 3 is equal to E to the 0.06 times T. So now we've got our exponential, we've got it isolated, so we need to solve. So we solve an exponential by rewriting it as a log. And so when we're rewriting it as a log, we keep the base the same. So we're going to have log with the base of E. Well, we know that log base E is the same as the natural log. And so we write it as ln, natural log natural. And so the natural log, so log base E of, and then we switch our input and our output. So the 0.06t here is the input. It's going to become the output of my log. And the 3 was the output of the exponential. It becomes the input of the log. So we end up with the natural log of 3 is equal to, and then 0.06t becomes the output. So at this point, we can just solve. We can put the natural log of 3 in our calculator. And when we do, we get 1.0986. And then it keeps going. I'm not going to write the whole thing, but I am going to keep the whole thing in my calculator so I don't have to round until the end. And so at this point, we're going to divide by 0.06 to get the t by itself. And so when we just put the number that's already there and just hit divided by 0.06, we end up with 18.317. so on. And so we want to round to the nearest tenth of a year. That's what our instructions in my math lab over here tell us. And so the nearest tenth of a year would be 18.3 years. So it will take 18.3 years for this investment to triple, no matter what the starting amount was.